Okay, so I hope that woke everyone up. But let's get started with the layer 2 bridging panel. So today we're gonna talk about layer 2 bridges, and the discussion will be focused around how the bridging works around layer 2 and a lot of the aspects that many people are considering around shared data availability and how that benefits a lot of the layer 2 side of things for when it comes to bridging. So I hope that is a very interesting aspect for everyone here to consider, especially those very technically involved people that we have here. So as part of the panelists, we have Peter from Polymer, and then we have Jim from Catalyst, and then we have Josh from Astria, and lastly we have Connor from Celestia. So yeah, we'll pass on the mics, and then we'll have them introduce themselves one by one.
Yeah, hello everyone, my name is Peter Kim. I'm one of the co-founders for Polymer Labs, where we're taking IBC to all other chains. Currently it exists only in Cosmos, but we're taking it to Celestia rollups, zk rollups, and extending it beyond the Cosmos.
Hey everyone, I'm Jim. I'm a self-proclaimed cross-chain enjoyer, and I'm working on a new project called Catalyst, which is a bit in stealth, but it's essentially a solution to kind of the fractured liquidity that we see in the multi-chain bridging problem right now. And so pretty excited to unveil that at ETHDenver on Saturday. Before that, I was at Aave. I was head of experiments there, so new products and internal research. And I've been in this space for a few years now, as you can tell from my silver hairs.
Hi, I'm Josh. I'm the founder and CEO of Astria. We're building the shared sequencer network, which is more modular infrastructure within the Celestia ecosystem to make it easier for rollups to kind of decentralize their sequencing.
Hi, I'm Connor. I'm a researcher and an engineer at Celestia, working on Rollkit. Rollkit is a modular toolkit for provisioning sovereign rollups on any DA layer, such as Celestia.
All right, thank you very much for the panelists' introductions, and I will also introduce myself. I'm Yuki. I'm a researcher and an investor at Fenbushi Capital, and today we'll be moderating the panel. So I guess to get started with the layer 2 bridging, I will first head off with the first question, which is, what are the security assumptions involved with your projects or the infrastructures that enabling the bridgings for your projects? And start off with Peter.
Great, thank you, Yuki. So at Polymer, we minimize the amount of trust assumptions that we make. So with IBC, with IBC, you have light client header verifications. So basically, by taking the consensus proofs of other chains and passing that state to other chains, you securely pass along the information between those chains.
Yeah, I would say Catalyst is built on top of kind of AMBs or arbitrary messaging bridges. We are modular in kind of our configuration in which we kind of outsource the verification of the messages that we send. All that to be said, we're kind of a new wave of a cross-chain dApp where essentially we're not recreating a monolithic interoperability stack from scratch. We're inheriting the security properties of the other kind of AMBs that we're using. And we do it in kind of either a patchwork way, and so we can use something trust minimized like canonical bridges from L2 to L1, kind of similar to a Connects implementation. We can do something like zk light clients to connect two sovereign zones, or something like native IBC to connect Cosmos app chains. And so we are very much a maxi of modularity and a kind of fan of using the most secure AMB for each domain. And so that is kind of the ethos that we have in place when we're building our liquidity network.
Yeah, so Astria isn't strictly like a bridge itself, but when we're looking at kind of the properties we would want out of a bridge, or that are, maybe more beneficial to interact with kind of like our architecture, what we're looking at is separating ordering of transactions from like the explicit execution of the transactions, noting that for any given state machine, you have a deterministic execution from just like an ordered block. And what you're often getting with kind of like a committee of, say like an IBC style, Tendermint light client, bridging mechanism is that you're getting guarantees, or rather not guarantees, but you're getting a claim by a given committee that the state root of a given kind of sending chain is a certain thing, and then you just trust that committee, and that's kind of the structure of most of the existing bridges. So you could look at a Tendermint IBC bridge or an Axelar, which is essentially a different form of that, similar to a wormhole or a layer 0, or I'm missing one. But they're all fundamentally just a group of actors that are making an attestation to what the valid state from a sending side is, and on the receiving side, they just need to trust that assumption. Similar to like how kind of like a roll-up, canonical bridge is saying that the assumption is just built into the legitimacy of the roll-up as a whole. So what we're looking at here is, when we build this kind of shared sequencer layer that allows you to have a singular committee that does ordering for multiple roll-ups, you're able to have that kind of the portion of the trust assumption you need, which is the ordering of the block. You can do that kind of once if you do it with the committee that is giving you that guarantee. And then additionally, we're very much focused on the Celestia and kind of the shared DA ecosystem. And from that, you get an additional guarantee of the availability of the data for all chains within that single DA layer.
The sovereign rollups that you provision using RollKit are similar to layer 1 blockchains. So they have the security of a layer 1 blockchain, only instead of using their own validator set for censorship resistance and liveness, they inherit that from whatever DA layer they're on. Also, what's made possible by using a DA layer like Celestia, which has sampling light nodes, is trust minimized light clients become possible, which are close to all the same security as a full node, but the optimistic ones have the 1 out of n honest full node assumption, and those are very good because 1 out of n approaches 0 with a very large n. And if they're ZK rollups, then they also have to inherit the trust assumptions of whatever proving system you're using for that.
So I think for the response, and I think to just summarize, essentially we have the IBC guy from the polymer side, who's going the hands-on IBC, and also Jim is more like the I guess whatever works is the best, right? It's kind of like modularity maxi sort of approach, right? And then we have Astria side that is kind of Astria and Celestia side that is kind of like relying on the security of the DA that is the rollup is operating on top of, where the trust is shared for the bridging. So we see a bit of like I guess variations in ways that those bridgings can be done in the current space. So this kind of leads to the next question, which is for the L2 bridging. So as you can see, like L2 bridging could be done in many various ways via IBC, via DA, shared DA, etc., etc. But what do you think is special or not about bridging between L2 with shared DA? Anyone want to take that on?
So I guess we first have to specify what we mean by an L2, and I think there's kind of the current Ethereum assumption, which I think is reasonable to maintain, which is that you have a rollup, and the important thing about a rollup on Ethereum is that you have a smart contract on the L1 chain that is kind of defined as the canonical bridge, and the important part of this canonical bridge is that the fork choice rule for the rollup is defined by this contract on the L1, and so kind of relating this to Celestia and the sovereign rollup space, the key distinction between a sovereign rollup is that the DA layer, Celestia in this case, or you could use EIP 4844 and just use that, Polygon Avail, whatever, right? But the DA layer is giving you a guarantee that the data exists, but it is not defining what is the canonical chain for the rollup. And that's a very important distinction, because one of the kind of components you want to get out of a bridge, and when we generally say it's a trust minimized bridge, usually what that term means is that there's a shared view of the underlying data that is used to kind of generate that rollup. And then the other two components you need on top of that to kind of get, you have to rely on some trust assumption for this, is the ordering, and that is fundamentally the defining of the canonical chain in an L2 on Ethereum. That's given, guaranteed by the smart contract. And then you also need like the actual execution guarantee. This is usually given by, a fraud-proof mechanism. Essentially, you have some presumably bonded actor, right, that is slashable, so they have an economic reason to do this. Or you have, a zk proof that says, okay, we have proven this execution. And those three things are kind of the things you need. In traditional like L1 to L1 bridging, you don't get the data availability guarantee between them. And historically, we've bundled the ordering in the canonical chain into the execution of the state root. So like, it's kind of a question of like, what do you think of when like it's an L2? The way we view it as like with sovereign rollups is that you need, similar to an L1 to L1, some party to define the canonical chain, and therefore you need to have a bridge that is sending over that kind of like attestation of the fork choice rule, I guess, of the other chain. But you don't need the DA component, which is given by the shared DA. So I guess it's depending on how you kind of like modularize the whole stack of components you need from the bridging, will define your bridging assumptions.
Yeah, like I said before, sovereign rollups, very similar to L1s, and they might end up communicating over something that looks a lot like IBC. But unlike the IBC you see in the Cosmos ecosystem, where you might have some problems because they have separate consensus, like for example, you might have a long or short range fork that compromises the bridge, and that's why I've heard some people say that the interchain is only as strong as the weakest, or the chain in there with the lowest economic security. That is not the case with sovereign rollups because they all have the same view of block ordering. So you don't have to worry about some chain with very low economic security having a short range fork and stealing funds across a bridge or something.
And Jim or Peter, do you have any thoughts from the IBC perspective coming from?
Yeah, happy to add a bit of context from like the Polymer IBC side when it comes to connecting L2s with shared data availability. Basically, as of now with IBC, most people understand it as only being able to prove consensus and state between chains, but one of the major innovations that we're pushing for in Polymer is conditional light clients. So when you break out modular blockchains, actually, typically with monolithic blockchains, you have one light client that passes the information from the different chains. With modular blockchains, by breaking out the components, we actually need to send the proof of each of the different modules between the other blockchains. So to do so in a way that still has a holistic view of that chain, we need each light client to recognize and to only pass on the information once it's conditionally approved of the other light client. To make these kinds of changes to IBC light clients, we're actually going to be publishing some of our research on how we change core IBC itself so that it can support this.
Yeah, maybe just last thing to add. As you look at, bridging from an L2 context, let's take the instance in which you're sharing the data availability layer. Like, when you look at it from a fraud-proof perspective or fault-proof perspective, you do have that challenge period, and so that is a kind of safeguard and kind of a finality latency that's in place in order to allow for kind of certainty of execution and finality into the shared DA, or also for security if you're looking at it in an Ethereum context. That is obviously from a user's perspective. Let's say you're bridging from one optimistic rollup to another, or really anywhere. You have to wait for that 7-day guarantee, at least as it stands right now, right? And so with the shared DA, what's really powerful is that you can have kind of entities that are essentially running fraud provers themselves. And so they're looking into kind of the historical transactions that are happening 7 days back with an optimistic rollup, and they're saying, oh, with a pretty high likelihood that there isn't kind of a rollback or a challenge that needs to be instantiated. And so they can actually loan that money on behalf of a user. And so you can kind of think of it as like a fast liquidity or fast withdrawal or any sort of fast finality that a user can get. And so that's really powerful from a finality perspective, is we kind of need that evolution of another entity in order to provide for that. I think when you look at it from a validity proof perspective or a validity rollup, you can kind of have kind of that proof of execution of sorts. You have the snark of the actual state transition, so you can have entities that are essentially running that as well and essentially providing the finality almost instantaneously. But I do want to flag that that's only in the context of like a centralized prover, right? So you're trusting that this prover is aggregating the necessary transactions and in the right sequences and posting the DA to a shared DA layer and then doing so. But within a decentralized context, that gets a little more complicated, and I don't think you necessarily use a validity proof right off the bat from the L2. You might have to do something like proof of consensus on the L1, but again, within a shared DA layer, that becomes quite trivial.
I see. So I guess from what I hear, basically the idea is that with the shared DA, there would be a possibility to achieve like a soft and fast finality to the bridging transactions that are done via, on top of Celestia, on top of like some sort of DA. And then on the other hand, you have, IBCs that are generally applicable to, I guess, most of the, conditions of bridgings between L2s or even between L1s as well. So I guess there's a bit of a differences there. And I believe there will also be some more nuances in terms of like cost and whatnot. But yeah, it's a super interesting topics to learn about. I guess this kind of like leads to another questions, which is relating to like the other factors related to bridges. So a lot of the time we talk about bridges in the context of like securities and whatnot, but there are also many other aspects about bridges, such as customizability and composability and extensibility, right? When it comes to bridges and how it is, easily integrated into projects and etc. So I wanted to also like ask the panelists here, what are the factors that you value the most about bridges besides security? Anyone want to take it off?
Yeah, so I guess I even propose like another aspect that we're actually seeing kind of like play out here, and it's like fundamentally it's like convenience or like user experience, right? So if we look at the state of like L2s right now, right, like the one I'm like more familiar with, right, is like Arbitrum than Optimism, but like we see a large amount of volume, like, and most of it going through GMX. And what we're actually seeing here, right, is like arbitrage between GMX and Binance. And the naive assumption would be, it's like, oh well, like how are they rebalancing all of this liquidity frequently to like kind of as like a mid-frequency market making aspect, right? Fundamentally, they're just bridging through Binance, right? And so like Binance and Coinbase and other like centralized exchanges fundamentally are bridges with the trust assumption that you're presumably not going to be rugged by Binance or Coinbase or whatever, right? So they're meeting that goal. What we're also seeing is, again, in the optimistic bridges, you can wait this 7-day fraud window and you can have high security and like trust assumptions that your funds won't be stolen and they went through, notwithstanding like fraud proofs and whatever, but we just assume enough people have kind of looked at the chain in a 7-day window. But what we're also seeing, right, is people using Axelar wormhole layer 0 to do bridging between these rollups and any other L1, and fundamentally they're not now kind of like working with the trust assumption of a withdrawal window. They're just saying, oh, well, it's good enough for me to trust the Guardian set or whatever kind of committee of this other kind of like third-party bridging solution I'm going through. So one of the things I think we should keep in mind when we look at these bridges, we say, yes, this one has the best security guarantees, but it's a similar argument to people saying, oh, the best tech will definitionally like win. You're like, no, the thing that users use is going to be more important. If you say this thing is technically more correct, but users don't care because the user experience is low quality, it doesn't really matter if it's a better piece of technology or not.
The most scalable and user-friendly consensus protocol is JTMB consensus. Just trust me, bro.
Full stop. Full stop.
So, the optimistic rollups you have on Ethereum, like Arbitrum and Optimism, have their slow withdrawal periods, and not everybody wants to do that. So it's great if there's some sort of very trusted, very user-friendly thing that they can use to just get some coins over there. But then the nice thing that you get from it being a real rollup is once you have some like wrapped ETH from a trusted or centralized bridge, you can then swap it for some real ETH that was bridged on there through the withdrawal period. And if there's ever a liquidity imbalance, then that creates a big incentive for a whale to bridge a bunch of ETH up and create that liquidity for these users who bridge the user-friendly, easy way. And it ultimately works out pretty well. But another property about bridges that, besides security, that's good to think about is like, can the bridge be built permissionlessly, or do the chains have to be aware of each other? So like with IBC, I believe the way it works is the chains have to like handshake. So basically they have to make themselves aware of the chain that they want to bridge to with a software update, and that's like tricky. Off-chain governance of a open source software project can be tricky sometimes. So we've been talking about the idea that like you might be able to build bridges by implementing the state transition function and fork choice rule for a rollup as a smart contract. And then if the smart contract, or like if the chain's VM can query the DA layer, then these smart contract bridges from sovereign rollup to sovereign rollup can actually be trust minimized. So that's a cool idea we've been experimenting with now.
Jim?
Thank you. I think just to add on to what Connor was saying, it's actually not that complicated once you establish the IBC connection, like that initial handshake. The tricky part is more so the relayer incentivization for passing the packets between the chains. That's where the cost comes in. But going back to the question, I know the question is more so on like what else is important other than security, but I think me personally, and I'm obviously biased in this, but security is obviously the number one most important thing. Like over the past 2.5 years, we've seen over $2.5 billion lost. With the other side of that though is that with like my background, like I'm more so on the business side, I'm more so like actually using all these applications. I agree with Josh that user experience is clearly king when it comes to like what wins out in this market. Back in 2020, 2021, people didn't really care how decentralized BSC or Polygon or Solana were. When Ethereum gas prices were so high, everyone kind of switched over. But yeah, I think the end state of interoperability, it's going to be secure, it's going to be composable. People are going to be able to make transactions across 4 different chains without even realizing that they did so.
Yeah, I would echo what Peter said, just also showing my bias here. I think the best thing about a bridge, besides security, is safety. No, it's the same thing. It's the same thing, guys. Security is the most important thing. I would say if I had to put something as a far, far, far second place, it would be customization and flexibility. And so is there an intelligence layer that we can put on AMBs in order to allow for a laxing of security properties for the use case of the packets that we're passing? And so an NFT or a Web3 social kind of transaction or a gaming mint probably doesn't need trust minimization. I think you can go with a just trust me bro type approach. But kind of echoing on Peter's analogy, right? Early 2021, we saw a lot of ETH killers, a lot of all L1s come, and basically when you look at the scalability trilemma, they're like, dude, like this centralization, that's a psyops. Like I really want to just make really fast, cheap things. And flash forward 2 years later, well, they're doing okay, but they didn't kill ETH, right? And that's because people don't want to make that trade-off. And I think when you modularize the interoperability stack and you have that level of customization, you can have easy user experience with a multi-signature TSS type implementation, but you can still have the security of a trust minimized zkSync approach as well. And that kind of flips the interoperability trilemma on its head, so to speak. Not that I believe in that as a heuristic for what the trade-offs for a bridge could be, but I do think modularity and customization will help in that dimension. But I still think security is the best thing, and I don't think that will change anytime soon, for me.
I'd like to touch on one thing we didn't really discuss, and it was in the question, was like composability. I do think that's like a legitimate thing to think about, because what we've seen, is kind of 2 broad categories of bridges, right? You can see like a consensus bridge or like a state bridge. And what I mean by that is like, you see a state bridge, and this is like your EVM to EVM bridge, and because the state machines are like composable, or it is relatively, like you can validate another EVM chain within an EVM chain in like a reasonable capacity, whereas if you look in like, Cosmos and really more accurately like Tendermint chains, right, a Cosmos chain can validate the light clients of like a Tendermint bridge, right, whereas going from, Peter, and this is like something you're going to be like very familiar with, right, it's like going from like Tendermint to, an EVM chain is like difficult to do due to just like, inherent difficulties in the curves and like how the signatures are like aggregated among each other and the cost of validating that within a given state machine. So I do think composability is also valuable, but to some degree, right, it's like a question of like, centralization isn't like necessarily the right word, but there's a question of like from a business sense of like when you're making a bridge, how are you monetizing? Is it more valuable for you to have a technology that is composable enough that you can satisfy all use cases, or do you just kind of bound yourself to, you know, one specific venue that has kind of like more, you know, liquidity within it, and you say, okay, I'll just satisfy EVM chains, or I'll just satisfy Tendermint chains. You know, you can obviously see like a benefit of like if you could have both of those, that would be like better from like at least a business use case of a bridging technology.
Yeah, I guess just to wrap up my thoughts on this topic, with centralized bridges, they're not a problem until they are a problem. You know, one of the co-founders of Nomad tweeted like 2 days ago about how projects today building off of interoperability solutions that, I'm paraphrasing, you can check the tweet, but projects today that are building off of interoperability solutions on the market now don't realize what trust assumptions or security trade-offs that they're making. You know, I also had an opinion that like when you want to get to market quickly, a centralized solution is much easier, much more quick to build. But if you're really pushing for true innovation, going for a decentralized, secure route, you know that takes time to really flush out because at the most raw level, it's more expensive. Like when you have to verify the state of other chains.
Right. So I see like there's a bit of a tug of war between centralization, decentralization, and also the verticalization of the types of bridges that perhaps may accommodate one use cases over others, as you know, some of the panelists have alluded to. So I guess yeah, that would be also a very interesting stuff to observe going forward with the bridge landscape going to the market. I guess the next questions could be a bit spicy, I guess, but you know. So you know, as the bear market hits, and a lot of the TVL and the user have kind of converged to a lot of those, I guess, layer 1 or layer 2, one or two of those layer 1, layer 2, and we see those kind of liquidity and user convergence happening in the space. So the questions I have to the panelists here is, how do you see the bridge will continue to play an important role among such kind of landscape of liquidity and user convergence? Anyone want to take it off?
Yeah, I could go ahead. I have a feeling that the four of us are probably sharing in the hypothesis that the future for blockchains are app chains. I think when it comes to how liquidity flows, you know, I would separate capital into two different categories. One is like ape capital, one is like smart/conservative. I think the smart/conservative capital is going to flow towards app chains or applications that are that have utility, and then the ape capital is going to go towards where the greatest incentives are for liquidity mining. I think as it relates to bridging, though, at least with our hypothesis, at least with what we're building with Polymer, all of these rollups, all these app chains in the future, as they deploy off of projects like Celestia, once we enable optimistic IBC, once we enable these different flavors of connectivity, they will already be able to connect, and the liquidity will flow through projects like Catalyst.
Yeah, I guess this kind of question gets at like the fundamental question of like, why do you even want a bridge, right? Like the original Ethereum vision, right, of like the world computer implied there would be one shared state machine. Like, you know, for better or worse, that is like not what we believe to be like a scalable solution anymore. You know, you can make arguments with like multi-chain, interchain, whatever term you want to use, right? But like there are multiple state machines that are distinct from each other, and there is like liquidity that wants to flow between them. And like what a bridge is useful for is like, you know, if you stand up a new, you know, chain, whether it's an app chain, whether it's a new monolithic chain, modular chain, you know, whatever, right? But like fundamentally, you need to have capital on it, right? Like we are in like a financial, like space, right? Like it's not just a technology space. It is both a finance space and a technology space. You need to have liquidity to be able to do things. How do you get liquidity? You know, in a bull market, maybe there's a lot of kind of institutional or retail capital coming into the space as a whole. In a bear market, no, it becomes more mercenary, and a lot of new projects are going to be looking to extract liquidity from existing players in the space, and bridges fundamentally are like the mechanism to do that. The thing I think we'll see in this as kind of bridges gain prominence is the reality of like, you know, if you want to go launch a chain, right? And like to pick on like Coinbase, right? But like, why does Base make a lot of sense? Because the hard things when you're launching a new chain are, how am I going to get infrastructure providers? How am I going to get stablecoin issuance? And how am I going to get centralized exchange integration? Coinbase gets all of those for free out of the box. So it's like a no-brainer for them to launch a chain. If you're a new project, right, and you launch, you have a very large business development lift to try to get integrations to reach kind of the status quo expectation of a retail user to utilize your chain. Right now, we can see, you know, various kind of players in the space that may have an advantage by being, you know, easier or harder to work with to provide these services to give this kind of bare minimum bar for a competitor. Ideally, bridges are able to provide something, you know, to Connor's point about like permissionless, where you can say, no, you don't have to go have, whether it's a business development lift with some, you know, Oracle provider or centralized exchange, or an on-chain or off-chain governance process to get an IBC connection. You know, all of these things ideally can trend towards the space where you can stand up a chain and you can't get boxed out by incumbents saying, no, I don't want you to take my liquidity. I want to have a moat where my moat is I came first and I have, you know, existing liquidity. So ideally, if we see bridges kind of get more prominent, there will be less moats on that liquidity, and it will flow to whoever is providing the best environment for that liquidity to be offered. You know, whether that's Ape Capital, whether that's Smart Capital, right? We want to see the users have the, you know, flexibility and ideally the safety in their bridging to move capital where they want it to live, rather than ending up in a situation, you know, similar to TradFi, where you say my money exists in one place and it is very expensive for me to do a cross-border transaction to get that somewhere else I want. It's not worth me moving it because the rate's going to be 5% on a remittance or whatever. Ideally, we move away from that world.
Yeah, I would say 2 points to your question, and maybe just echoing my fellow panelists. One piece is that liquidity, of course, is the name of the game. It kind of powers the infrastructure that we're building for. And the infrastructure that we're laying in place right now is going to be well positioned for the next cycle. With that said, I'd say liquidity for liquidity's sake is kind of a Faustian bargain of sorts, and borderline excessive and unnecessary from a business strategy perspective. And so I think a really good example is if you look into Stargate, I think in the initial stages, they really wanted a lot of liquidity in their platform. And then if you're following their Commonwealth Forum posts, like me, like a huge nerd, you'll see that they're actually winning off from incentives because they realize that the capital efficiency gains that they have from incentivizing additional liquidity actually doesn't facilitate more transactions or have a kind of tighter price execution than what they anticipated. And so, again, liquidity for liquidity's sake is unnecessary. With that said, you know, liquidity is important, and I do think even in a bear market, there's enough liquidity to provide the value or the transfer of value that we need to see in order to enable a multi-chain kind of infrastructure. And so that's kind of the first reaction that I have to your question. The second reaction that I have is when you look at a kind of end state vision for what we're trying to build within the space, essentially it is a multi-chain vision in many ways, right? App-specific environments or ephemeral environments that are spun up in order to perform a certain goal. And in that environment, what needs to happen is some form of interoperability or some form of connectivity to where the financial assets or to where the user relationship is with the chain, right? And I say that with a qualifier because you don't necessarily need to bridge assets to a new chain in order to use it. And so if you have that kind of like application-specific instantiation vision of like every application having its own execution environment, you need some way to build a abstraction layer on top of it so that users can still derive the benefits from an application-specific execution environment without kind of the burden of moving them. And, you know, some form of a shared, you know, state machine that, you know, Josh kind of alluded to for Ethereum is kind of dead. That's not going to happen anytime soon. And so even in a low liquidity environment like the bear market, we're still building for something that everyone, I think, is interested in kind of pursuing to the future.
And Connor, do you have anything to add?
Sure. It's a bit of I'm a little bit torn on this one between like the app chain world and the monolithic shared world computer world. Because if you've ever been to a Solana hacker house, you've seen wall-to-wall people just building smart contracts and front ends for their idea, not worrying about bridges, not worrying about interoperability. Like, they just write their contract, and it's immediately composable with the entire rest of the ecosystem on the chain. But what makes app chains really enticing to me is that they actually give you a way out of the dirtiest secret of DeFi, which is that oracles have a really scary honest majority trust assumption for safety. And when you're in the monolithic world, your only option for oracles are like oracles with that assumption. Whereas if you're in the app chain world and your app's validators are doing the job of oracles, they can actually be held accountable when they rug your protocol. You can actually slash them out. Like, you can have the users slash them out, which I think is like, that's so important to cut out like the scariest central failure point in all of DeFi, that it makes the app chain world very worth looking into. And if you're in the app chain world, then you need bridges. Bridges are inescapable, so we should build the best bridges for that world.
I see. So it seems like I also wanted to echo some of the sentiments that I see from the panelists, but I guess, yeah, the role app or the app chain future is quite imminent, and it will be also super interesting to see all of the bridges that are going to be very much useful for all of this role app and app chains that are coming out from on top of Ethereum or even outside of Ethereum. So yeah, I guess for the last questions that I have for panelists here is, I guess, a bit more forward-looking into 2023, 2024. What are you most excited about bridgings and all the shared DA and whatnot on top of layer 2 going forward? Anyone want to take it off?
Sure, I can kick it off.
All right.
I'd say for me, what I'm most excited about is to stop seeing people lose their money. I think that once there's a decentralized secure option, once IBC is set as the industry standard for cross-chain messaging, we'll all have the ability to grow as an ecosystem without people getting rugged left and right. I think with the adaptations we're making IBC, with optimistic IBC, zkIBC, I think extending IBC across other chains is gonna bring us to that future, and Polymer intends to be the IBC transport hub for that.
I think, like as what you've been alluding to, we're definitely in kind of a path of almost inevitability for role apps or app-specific chains. For the doubters in the audience, you can talk to me after this panel, and I'll show you more proof points and why I'm absolutely certain this is going to happen within the next 24 months. So if you're building in the paradigm in which you're literally clicking a button and you create a new execution environment, either using shared DA or off-chain DA or shared security layer or what have you, right, click, click, click. I just made 3 blockchains, and that is actually happening right now and will be much more mature in the next 24 months. What is the infrastructure that we're building in order to enable that future? I don't think enough people are really asking that question, right? Everyone wants configurable blockchains, change the gas prices, native gas token, off-chain DA, high throughput, parallel execution. Very important things for sure, but there are other things that make blockchains. There are oracles, like what Connor was alluding to. There are bridges, there are block explorers, data indexers, wallets. And so how are you building a world in which everything comes out of the box when you're creating this modular blockchain? That is super important, and that is something that I'm personally very excited about, and I'm personally building on, and excited to unveil soon.
Yeah, so I think the thing I'm most excited about is it finally feels like the tech is kind of like getting there that we've been talking about for, the better part of 2 years or 5 years if you've been around for a while, right? We're starting to see, the zk EVMs be on their like 5th soft launch or whatever, and so we will finally see an actual first zk EVM potentially, as soon as this year. But kind of alongside that, right, like it's less the like specific details, but I think more the general kind of institutional understanding of, the zero knowledge technology is probably like the most kind of like optimistic thing where we're seeing things like, Polymer Labs work on like zkIBC, like Succinct Labs work on like a zero knowledge form of like, Ethereum to like, POS. That helps us with like composability between chains that maybe, don't have an easy ability to verify, an alternative chain's consensus algorithm. So that opens up the bridge space. And then we're seeing with these ZK EVMs or with like the ZK VMs like Risk Zero, we're seeing, a relatively lower barrier to entry to, prove whatever kind of, state machine you want, whether it's, the EVM has seen a lot of focus, but these app chains can potentially just be generically compiled to, RISC-V, and then you can use a Risk Zero's, RISC-V ZK VM, similar things to what you've seen with like Optimism doing this over, fraud proofs for like, I think they use like MIPS or whatever, right? But this general kind of technology stack to say like, okay, what we actually want is like a generic black box that says like I can put whatever I want in on the left side, and on the right side I'm going to get a proof, and therefore I can use that proof in an interoperable way with all these other things. And we're just seeing the tech reach a point where the barrier to entry for something truly novel is getting low enough that like the design space becomes very, very broad, rather than you saying, well, we'd like to do this really exciting thing, but it just doesn't work with the existing paradigms we have, and we have to do this so iteratively because it's just impossible to make these like really big level change things. I do think we're starting to see the tech get to a point where we can see really, really innovative new stuff.
I think once we have really good bridging enabled by shared DA layers, it'll lead to opening up an era of experimentation. With these rollups, there's like so many different like decentralized sequencer schemes and like proving schemes and like VM possibilities and different ways to resist censorship, like forced transaction inclusion, permissionless block proposing, or inbox. And we can constantly come up with new schemes like this and try them out and build them. And then like once they're launched, if there's good bridging, people can really like move their coins around from wherever and try it out. And we can really figure out what works and then eventually end up in a much better place as a result of all this experimentation.
Thank you very much for all the things that you guys are excited about. And I see that there's one very core aspects of the layer 2 bridging, which comes to like the raw app thesis and the app chain aspects that I think will be something that going to be super exciting to observe. As Jim also mentioned that in the next 24 months, a lot of those kind of stuff is going to come out. People are going to be experimenting with modular execution layers like Fuels and other VMs available in the space. So yeah, that's going to be super exciting, and I hope everyone will be keeping up with all of those amazing founders and teams coming on to the panel. And again, I wanted here to also thanks all the panelists and the founders for joining the talk. And it was a very interesting, insightful conversation that we had. Thank you very much, and a round of applause.